Hi everybody. My name is Kevin. I'm from Map Protocol, and I'm responsible for product and dev ecosystem in Map Protocol. Today, I will give a brief introduction on our projects, including our technical overview and our future plans. As everybody knows, Map Protocol is always aiming at empowering Web3 apps to thrive in the Omnichain future with our Omnichain infrastructure. We don't have any privileged role in the whole process, and our process is 100% compliance with Nakamoto style. And most importantly, Map is never a bridge. So to gain a better understanding of Map Protocol, I will break technical overview into 4 parts, including our project's technical structure, the innovative design of our relay chain, and Light-client network, and also a cross-chain workflow example. So let's get started our technical overview. So the first part I will go through is our 3-layer system. So Map Protocol contains a 3-layer structure, which is designed to be a dApp oriented and composable. So let's start from the bottom. So the first layer, the very bottom layer, is our protocol layer, which is responsible for cross-chain verification. It maintains all self-verified Light clients deployed on each destination chain, and it also contains the interchain program maintainer, which maintains the Light client status. Zero-knowledge technologies also belongs to this layer, and it speeds up the whole verification procedure. So that's our protocol layer, which is very deep and bottom. And the middle layer is our MAPO service layer, which is similar to Google mobile services. It includes Omnichain toolkit, such as cross-chain votes and interchain messenger, which is also responsible for delivering cross-chain transaction and build the transactions proof data for Light clients to verify. The Map Protocol service is now provided by Butter Network. It's a cross-chain aggregator built upon Map. The app can also choose to develop their own tailored version by forking our MAPO Omnichain service and installing Messenger SDK. So that means Messenger can deploy their own, can tailor their own cross-chain logic and using their own messengers to delivering their own transactions. So that's our core layer called MAPO service layer. And the very top layer is called MAPO application layer. So in this layer, something like the DeFi, swap, lending, GameFi, NFT marketplace, DID can all achieve Omnichain compatibility through our infrastructure. No matter on which chain the main smart contract are deployed, the apps can automatically cover all chains powered by MAPO Omnichain network. So yeah, so something like Butter, and there's lots of other program already deployed on Map. It also belongs to this MAPO application layer. So that's how the MAPO technical structure is. So another part, for the second part, I'm going to talk about the innovative design of MAPO relay chain, which is very core in the Map protocols projects. So it's considered to be the backbone of our whole projects. The innovative design of MAPO relay chain makes it to become the hub for both EVM and non-EVM chains. Unlike other relay chain projects, Map relay chain integrates mailing, hashing, and signing algorithms originated from other chains as pre-compiled contracts. This improvement significantly reduces the difficulties of Light client development, and it also makes the relay chain itself become isomorphic with both EVM and non-EVM chains. Here, I can think of a simple example to show how difficult is the Light client development. So Rainbow Bridge on Near is trying to achieve a trustless cross-chain verification using Light clients. Due to Ethereum's lack of native support for the ED25519 algorithm, deploying a Light client for Near on Ethereum would require rewriting it in Solidity. Even if it were possible to rewrite, the verification process will still exceed Ethereum's gas limit by a significant margin. As a result, they ultimately chose an optimistic solution, which involves waiting for cross-chain transaction that could take up to like 24 hours. So Rainbow Bridge, so we generate this idea from Rainbow Bridge as well. So that's why we just pre-compile ED2 5519 on top of Map Protocol, Map relay chain. So that's why we can achieve bidirectional light clients on both near and Map relay chain. Yeah, so that's our innovative design of Map relay chain. And so the third part of the technical overview is about our Map protocols like verification and the maintenance network. So it's another core pillar of our Omnichain infrastructure. It is responsible for verifying every cross-chain transaction. So in a light client cross-chain solution, we need to deploy a light client of the other chain on the current chain if we want to achieve interconnection between two chains. For example, if we want to achieve, like as I said before, if we want to achieve near and Ethereum using light clients verification message, so we have to deploy Ethereum light clients on top of near chain, and we will need to deploy a near light clients on top of Ethereum. So that's how we achieve like bidirectional verification using light clients. However, if it is a multi-chain solution, then each chain needs to deploy the light clients of all other chains. This approach consumes significant time and personnel resource because different chains has different signing and hashing algorithms, as we mentioned before. The difficulty of implementing the different signing and hashing algorithm, the difficulty of implementing the consensus encryption algorithm of chain B in the development language of chain A can be imagined. On the Map relay chain, the presence of like pre-compiled contract have prepared us for the scenario of multi-chains. To achieve the Omnichain connection, each chain only needs to deploy a light client of Map relay chain, and therefore the network forms. So in our Map protocols verification maintenance network, we only need to deploy the light clients, Map protocols light clients on top of the destination chain, and each destination chain's light client will be deployed on the Map relay chain. So there forms like a verification network, and the cross-chain message can be verified on top of Map relay chain and then forward to the destination chain. So this is how the verification process is achieved. And I will go through the example later. So for the light client development for POS chain light clients, we only need to store validator's public key and vault weight. So there's no need to store a block header because the transaction can be self-verified according to each validator's signing and the vault weight and their signature. And we only need to verify a new set of validators, and it gets self-updated. So the proof of a certain transaction and event is included in a Merkle proof and a corresponding block header info, which is provided by maintainer. And for POW chain light clients, we need to store latest N block headers. So this is gonna consume a little like saving storage. And we need to verify new block header following consensus protocol, and it gets self-updated. So for proof of a certain transaction is also included in a Merkle proof. So right now we already, since the Ethereum upgraded from 1.0 to 2.0, so there's no POW chain connected with Map at the moment, but we are exploring the Bitcoin verification as well at this moment. As for the maintainer, so maintainer is a non-privileged role to deliver the block headers to the light clients. So it helps the light client to get updated with the latest significant block header on the source chain. So yeah, so here I will finally give an example of how cross-chain works in Map protocol. Let's take Alice as an example. So if Alice wanna transfer 100 USDC from Ethereum to Near using Map protocol, so this is workflow. I'll go through one step by one step. So first, Alex gonna lock 100 USDC in the vault deployed on top of Ethereum. So this vault Then after receive the 100 USDC from Alice, it's gonna emit the events. So the event says that Alice logged 100 USDC, and the source chain is Ethereum, and this destination chain is near. Then the messenger we mentioned before, which is responsible for build the proof data and delivering transaction. So you're gonna listen to this event, and then you're gonna find the transaction in the Ethereum chain, and it will build a Merkle proof according to the block and transaction, and you're gonna form the proof data. So then the messenger is gonna deliver, that's gonna transfer this proof data to the map relay chain. So in the vote on top of map relay chain, it will verify this proof data against our Light-client of Ethereum. So the Light-client, after received the proof data, you're gonna verify if the transaction is valid or not. If it's valid, then the vote gonna help mint Alice 100 mint Alice 100 temporary MUSDC, which is a temporary asset on top of Map Protocol. And this mint event can also specify the destination is near. And after mint happens, they're gonna follow by another burn event, because after the burn event happens, you will leave a trace on map relay chain and let the messenger to pick up this transaction and forward to the near chain. So after this burn event happens, it will burn 100 temporary USDC on top of map and says that destination is near. So the messenger will also listen to this event and do the same thing as Ethereum, and it will form another proof data according to map relay chain, and will transfer this proof data to the vote on top of near. So the near vote gonna verify this proof data against map relay chain's Light-client. And if this proof data is verified, this vote is going to transfer Alice 100 USDC on near chain. So this is how our cross-chain workflow. So yeah, so basically it involves all the messenger and the Light-clients and all the proof data, and this is basically how our cross-chain workflow works. Yeah. So this wraps up all the technical side of our current progress of Map Protocol. So those technical progress what makes us here today. So after finish all these things we were done in the past, I want to talk about the mission beyond. So there are like 3 goals we want to achieve. So wait a sec. So before we wrapped up all the technical overview here, I want to show some actual example we're building at this moment. So here is a demo of our Map Protocol's MOS, the cross-chain verification network. So this demo basically is called the Omnichain dictionary. Due to the time constraint, I cannot show the whole process of it, but everybody can go and try out in this address here. So what it does is actually you type a word and the brief description here on Polygon. Let's say here, what's the gateway to Web3? Just add an answer like Map Protocol here. So and we connect wallet. Yeah. So so if we type it here and we want to forward this message to BNB chain. So on the BNB chain, we can verify what's the gateway to Web3. It will give you the answer Map Protocol. So the whole thing here, all the steps here showing all the contract the cross-chain message goes through, and we can verify those things also in the GitHub here. Yes. So the Omnichain example can be found in the Omnichain example UVM contracts, and there's Omni dictionary. So this is basically a simple example which can be found there, and everyone can try out in this website as well. So due to the time constraint, I cannot show the whole process. It might take like 2 to 3 minutes from Polygon to BNB chain. And also, I want to show the border. So Swap is using our MOS as a bottom layer for verifying cross-chain messages. It's basically this is our first version. It's basically a cross-chain aggregator for user to transfer tokens, to cross-chain transfer tokens. As you can see, like if I want to transfer like one BNB to Map Relay chain, it gonna gives you the roots and the way it follows. It's gonna pancake regime, and also those things are as simple as a current swap aggregator, DEX aggregator. So this is bothering everyone can go try out as well. So it's working right now. And also we are working on the second version of Butter, which refines all the UIs and the roots, and also it integrates some other services as well. So the Butter is our current working example. Is our product level example for everybody to try out. It's a cross-chain aggregator. This is a new version we are working on. Let's just give a glimpse on this as well. Sure. So let's go back to the introduction. So that all wraps up all the technical overview of our existing progress. So I want to talk about the mission beyond. So there are 3 goals we want to achieve in the future. So first, the Omnichain expansion is always on our must-do list. Then we want to tailor our MAPO Omnichain service, let's say the MOS, to a next level. And last, we want to explore some excitements in the old-fashioned Bitcoin ecosystem, where the Nakamoto style is originated. Yeah, that's our 3 goals. I will talk them one by one. So first one is like keep expediting for Omnichain future. So Map team is always expediting the Omnichain future, as everybody knows. So to achieve this, the core dev team keeps expanding horizontally to connect those exciting renowned blockchains such as Cosmos, Polkadot, and Clayton. So for Cosmos, we are in progress of merging our new proposal with Cosmos team. So we want to connect our map relation, build like a Light-client to verify between transactions between Cosmos and map relation. And for the Polkadot, we already built our contracts on top of Polkadot using BFeed consensus, but since the BFeed doesn't integrate it in the Polkadot ecosystem, so this progress is held at this moment. And for Clayton, we already connect with, we already established a connection with Clayton at this moment. And besides, we are also keeping our eye on the emerging innovative new blockchains like Sui and Aptos. So that's why we want to connect between all like EVM, non-EVM chains. And also we are like research and development like studiously to blur the boundary of EVM ecosystem and also non-EVM ecosystem, because right now we already connect with Near, which is non-ecosystem, which is non-EVM ecosystem, and we want to connect with like Polkadot as well. So we want to expand our Omnichain future with both EVM and non-EVM inside of them. So for another goal we want to achieve is keep building for the next generation Omnichain tool. So the core team will first, our team is already do that. So the core team will first be upgraded with contract structure optimization in our map Omnichain service contracts, which is in the GitHub already right now. And we will do a lot of like modularizations with different functions. For example, like vault function, staking, and cross-chain like general message passing functions. All we want to like modularize them in our MOS. Also, we will provide our like developer-friendly docs and examples, such as the example I showed before, the Omnichain dictionary examples. We will give a lot more examples and more like step-by-step tutorial for user to how to using MOS and how to build Omnichain dApps. We will give more example like that in our docs. And we also will, we will build a lot of like innovative applications development with our MOS. So we have a like side team Map Protocol who's building building innovative dApps. So right now we already issued our MRC20 Omnichain token standard, which can be also found here as well. So as I can show here, so which we already issued our examples with our MORC20. So this can be also found in our Omnichain examples here. So basically, the MORC20 is like Omnichain token, which can contain bridging and bridge out, like transfer out, transfer in functions automatically in the contract. So user don't need to, after deploying those tokens, users don't need to find a specific bridge to transfer their token. So the token itself contains the cross-chain functionality automatically. That's the MORC20 we are building at this moment. And also for the MORC20 Omnichain token, we also build Omnichain token launchpad for this, so user can using our launchpad to easily issue the MORC20 token. And there's a native bridge to help a native UI for user to cross-chain their Omnichain token, and the widget which can be integrated on top of their website, so user can use them to deploy MRC20 easily. And also, we also upgrade our verification process using zero knowledge. So our zero knowledge is implemented with Pro 16, and so it's used to reduce the gas cost for verified our signature processing Light-client. So it will be significantly reduced during the signature verification process in the Light-client. So after this one, we will go talk about the third goal, which is keep contributing in the Bitcoin ecosystem. So we already designed and launched the Bitcoin cross-chain standard BRC201, which allows users to indicate their destination chains, token taker, and amount in a cross-chain inscription. We're also building our all-around indexer for Bitcoin transaction, inscription, index, and decode, and it also comes with a customized MAPO scan explorer for visualizations, including those cross-chain transactions. So that's all work in progress at the moment. So the team is also exploring the similarity among LTC Light-client ecosystem, Litecoin ecosystem, and Dogecoin ecosystem. So and will support the other two ecosystems extensively with all the tools we built. So I'll show here. So the BRC201 is already launched. So it basically helps to indicate a cross-chain transaction from Bitcoin to other EVM-based chain or other non-EVM-based chain. So users just need to specify the destination chain and the extension, which means like a bridge out or bridge in, and the reference indicates the address, which is the destination address to receive the tokens. And also there's token takers, and there's amount. So the BRC201 basically is an extension of our existing BRC20. So yeah, here's a bridge out example, which is like, this is the destination address, this is the destination chain, this is the action it's gonna take. It's a bridge out transaction. Yeah. So here we also build our BRC20 API, which is an indexer. We expose some of them in this docs, and people can use them and connect us to use them. So those APIs are already included. So get the inscription list, get the inscription. Those are BRC20 token lists. So such of them are we build this indexer to help project want to achieve like cross-chain interoperability between Bitcoin and other ecosystem. So developers can contact us for using those APIs. So there is a side project, a team who's building building a BTC bridge from using our indexer and wallet service from Bitcoin to MAPO. I'll just give a glimpse here. So it's a BRC20 bridge built by another team using our existing services and tool. So it's connect with BTC and MAPO. So user can using so the list right now is set to MAPO token deploy on the Bitcoin ecosystem. So you connect on my wallet, connect with Unisat. So user can inscribe a BRC201 and which will be ready for transfer to another destination chain. Here I already inscribed 2 of them, which here says that the destination chain is MAPO, the 2 addresses here, and the amount is 1. So this is as simple as it is. So user just can transfer Bitcoin, transfer BRC20 tokens by using this bridge to the MAPO and other connected EVM chain. Here's history. It's a simple bridge using our indexer and the BRC201 standard. Yeah. So that's our 3 goals here in the that we want to explore in the Bitcoin ecosystem. Yeah. I guess that's wrap up for the whole session by introducing our existing progress and our future goals, and just show some examples in between. Yeah.